So for my last DIY PCB project, I attempted to build a mini wireless radio, and while I got all the components soldered on, everything looked perfect, it did not work as expected. I did get one of the LEDs to come on though, so not so bad, right? And when I look at it, I mean, everything was in place properly, so I think I did the soldering right, but yeah, I mean, I'm not getting it to work as a radio. So this one will have to go in the diagnostic and troubleshooting bin for now. But the project before this was a touchlight dimmer, and that was a total success. So I had one success, one fail. But today I'm going to be building a digital clock from scratch. Hopefully this one turns out to be a success. Let's get into it. Yes people, welcome to Teaching Myself Electronics. It's PCB Project Day, and today I'm going to be building a digital clock from scratch. But before we get into it, please hit that thumbs up button to like the video. Subscribe to the channel, your support goes a long way. Thank you in advance. Let's go. So the digital clock, a DIY mini project I picked up on AliExpress, cost about $6-7 I think. And the moment I saw it, I said, yeah, I need to do this. A lot of components, which means a lot of solder practice, working with components, placements, all of that. So yeah, pretty interesting. So I finally got it. So let's see what actually is in the bag. Alright, so we have the PCB board, piece of paper, instructions. No, these are not the instructions. Well, they are the instructions, but they're in a different language. So these have no use to me. So throw that out. Then we have the PCB board, nice flat rectangular circuit board, and right away I can see that we have some imprints on them that actually tell you where each component should go, the type of component. I mean, like you have R2, I know that resistors, and I can also see where the digital LEDs go, so on and so forth. So it's printed with what you can actually refer to as instructions as to where each component should go. So next, I can see that I have the LED, the digital displays, right? These are the digital displays. I have 6 of them, and then I have a little container here with the rest of the components and a strip of a lot of resistors. So yeah, quite a few components to get through. So first things first, I'm going to check the value of these resistors because I have a lot of them. They all look like the same color, same type, same color bands. So I'm going to assume that all these resistors are the same value. So right away I see that these look like a 1000 ohms or 1k kilo ohms. We have a lot of these 1k resistors on there. So alright, that's the resistors. That look good. I have a little bin now with some other components. Right away I can identify, I see some LEDs. I see some, these are our integrated circuits. I'm seeing capacitors, some other resistors which are different color, and I might think that those are maybe higher value resistors. So yeah, let me sort these out together, and then we can identify exactly how much of what we have, and so we can know where each component should go. Alright, so I have the components sorted, set aside just to see what I'm working with. I have a lot of resistors, we have some integrated circuits, LEDs, capacitors, and so on. I think I'm going to start with the resistors first, which is the most that we have. So let's see if I can get the resistors in and then do these one set at a time. So I'm just going to break off 2 or 3 resistors at a time and then drop them in the hole, bend them underneath. And then I'm just going to do this repeatedly, try to fill all the resistors in, and then do the soldering afterwards. I don't know if, I mean, some people might break them all off and then put them in. Doesn't matter really. Once you get them in, that should do it. And also, with these resistors, it might look easy. Well, it is easy, but it's something that you actually get used to, because you want to make sure these resistors are laying flat and as neat as possible. Alright, so yeah, I got them all in. Trying to get them as flat as possible. So now flip it over, and I can see this is looking like a rat nest. A lot of pins bent in different directions. So now I'm going to have to straighten these out and get them ready for soldering. Alright, so the pins are ready. I got them laid out as neat as possible. So now my solder iron is ready as well. I have that set at 400 degrees Celsius. And I'm going to also use some flux. But in a situation like this, what's the best practice? Would you use flux? Or do you use solder wire with more flux in the middle? Because flux will make it messy, of course. But I think the flux definitely will help doing so much resistance. So for me, I'm going with flux and just see if I can get everything flowing and soldered neatly. Alright, let's go. This is my favorite part, soldering. Soldering all day long. Alright, so for this I'm doing we'll call it now a particular set of resistors first. I'm not gonna add flux right across the board. So the plan is I'm gonna do this set of resistors first, solder it, do like two blocks if you want to call it that, and then I'm gonna just clip off the excess pins. And I must say, this solder tip, this bend tip, I call it the bendy tip, it is absolutely spectacular. I love it. It's small, it have a bend, and go into some hard to reach places. I used to love the knife tip, I used to love the bevel tip, but once I got this one, feel like it's no going back. Absolutely love it. So once I done the first block of soldering, I'm gonna clean up, clip off the ends, and then move to the next block. So rinse and repeat until I have everything completed. On the last batch now, and I must say, make no mistake, this was actually painful, but it was actually fun. A lot of soldering, a lot of clipping, a lot of resistance. Yeah, it was fun, I enjoyed it. With the clipping though, I want to point out something. The way I handle the excess pins that I clip off, I use one of my helping hands which has a magnet base. So what I do, I just allow the magnet to pick up each of these clipped ends that I clip off of the resistors or any component, because I don't like having these tiny metals all over the place. Works like a charm. But yes, this looks good. All the resistors are in. Let me turn it over and give it a quick check and see how the resistors are looking, because sometimes when you're soldering, you might push one or two of them out of place. So far, yeah, these look okay. Don't see any yet that's looking crooked. Well, yeah, there's one, the second one right there, and I see another one there. I mean, they're soldered, but just to have them a bit neat, probably come back and fix that one later. But for now, I'm gonna leave this as is and move on to. So I'm gonna do the LED displays. I have 6 of these. I've never worked with these before, but pretty simple. Just some pins inserted from on the board and solder it on the other side. Alright, let's see if I can knock these off real fast. Hold on, so before I install these LED displays, I just noticed I see some LEDs and some 470 ohm resistors between the LED displays. So you know what, I'm gonna drop these in before I go ahead with the LED displays. So first thing first, let me see if I can find the values of the 470 ohm resistors. We have 2 of them, and then we have 4 LEDs in between the LED displays. Alright, so here we go. We have 0.47 kilo ohms, so that's 470 ohms. So we're good with 1. So let me see if I can drop these in and then proceed with the LED display. Now for the LEDs. Alright, so now we're ready for the LED displays. Alright, so the only thing normally I have to look out for is make sure that I don't put them in upside down. The dot beside the number tell me that which is the base, so I can have them upright. This one was giving me a little bit of pain because it seems as if one of the pins were bent, so I had to put the base pins in first and then use my tweezer to direct the other pins into the holes. So eventually I got it. Yeah, they look easy to install, but they're not so easy because most of the pins were not straight, and it gave me a hard time to actually get them lined up properly with the holes to put them in. I had to use my tweezer, put one side in and use a tweezer to direct the pins into the holes. Took me a little bit of time, but yeah, eventually I got it in. So now it's looking good and I'm ready to solder. Flip him over, solder iron, flux ready, you know the drill, bend the tip, ready for action. Let's go. So these are short pins, so nothing excess to cut off. Look at the flux work, look at the bendy tip work. Yeah man, this is so good. Soldering is going smooth. I have the excess tip on the, I think those are the resistors that I need to clip off on the end and the LEDs, so that's fine. No issue. So same procedure. Let's get all of these soldered. Clip off what's excess is there, then do a clean up and then we should be good. That went smooth, soldering went smooth, flux, bendy tip, magic. Alright, so getting some alcohol now. I'm gonna do some cleanup, remove some of this excess flux, get the board nice and clean, and then I can move on to the next step. Next, I'm going to install the diodes and the capacitors. So when you start with the diodes, I'm going to just sort them out. We have 4 of them. Sort them out and then I'm going to put them in the correct place on the board. So these diodes that I have are the 1N4148 diodes. And if you look close on the board here, I already identify 1, 2, 3, should be 4 of them. So I'm just going to see if I can drop these in quickly, bend the pins underneath, and then move on to the capacitors. Diodes are in. Now for the capacitors. I'm going to start with the 30p ceramic capacitors. I have 2 of these. Look on the board, you should see the 30p with the C1 symbol. So I have a C1 and a C2. So we have a 30p C1, 30p C2. So these 2 ceramic capacitors should go right here. Up next, we have the electrolytic capacitor or the cylinder type capacitor that we're going to install. I only have 1 of this. So this one should go right here where it's a C6. And this is a 100 UF 25 volt electrolytic capacitor. Finally, we have 3 103 monolithic capacitors. So looking on the board, we see I'm seeing C4 103. One should go right there. We also have C3 103 and C5 103. So these 3 capacitors should go in this location on the board, and then we should be good and ready to solder. Same drill again, flux, solder, bend the tip, clip the ends, clean up. Getting there slowly but surely. A lot of components to install. Trust me, taking some time. So the next thing I'm gonna do the buttons and the switch, and then I'm gonna leave the best for last, which is the integrated circuits. Well, actually, I realized that I have some resistors that I still need to add in before I move to the switches. I have 3 2.2k resistors, and I have a 100k and a 10 mega ohms resistor. So I think I actually need to get these in first. So I need to measure the resistance to find out what goes where. If you look closely here, I have one spot here for the 2.2k, 2200 ohms. So I should have 3 of these, and then a 10 mega ohm and a 100k resistor. So let me measure these up and see if I can get them in before I move on to the switches. Gonna try to find the 10 mega ohm first, so I'm gonna put the multimeter at 20 mega ohms. First test, lucky. Alright, seems like this is the one. This is the 10 mega ohm. We have that one. We can put this one aside now. Alright, let's test another one and see what we have. This one is looking like, yeah, this is the 100k resistor. Alright, looking good. So the next three resistors should be the 2.2k, 2200 ohms. So let me go through and see if I can find those resistors and drop them in real quick. Resistors are in, soldering time again. Same steps, flux, solder, clip, clean up. Alright, so we finally got that out of the way. So now I can move on to the switch, the buttons, the power connector, and the crystal. Alright, so installing the button should be pretty straightforward. Just line them up with the holes, insert it in, and it actually stay fastened, so that's pretty good. So I don't want to tip any solder on the other side to hold it in place. But the next thing I'm gonna put in is this thing called the crystal. Crystal, I did not know what this was, so I had to do some research and then actually know what it's for. And it's pretty much, whenever you design any type of clock, you need a crystal because of the frequency and to keep accurate time. And this is a 32.768 kilohertz, and it's the clock circuit counts these vibrations to keep accurate time, and that's why it's important when designing like a digital clock or any clock of the matter. This is what the crystal is used for, pretty much. Next for the switch, and this switch, the switch can be tricky to install because when you put it in, it doesn't stay into place. You have to hold it with one hand and then have tip of some solder on the other side to hold it in place before you can solder all the legs together. I've got a tip of solder onto the solder tip, and I'm just going to put it on one leg just to try to keep it in place before I solder the rest of the legs together. Alright, so we are looking good. Soldered, and now I'm going to move on to the buttons. So the buttons, just going to add some flux, solder, nothing to clip because these are short, so this should be quick. Finally, the power connection, quick and easy. And that is it, looking good. I think we have one more step, right? And it's the ICs. After this, that should be it. And like I said, I saved the best for last. Actually, when I bought this project, I was looking at the ICs actually got my attention. I've never worked with these type of ICs before, so I don't know. I think it's gonna be a challenge. Look easy enough though. Just line them up with the board and slot them in. But I don't know. I'm concerned about the other top side of the IC that should go on this base piece. So let's give it a go. Let's see how well I can get these installed. Trying to get this IC installed, and it's not as easy as it looks. I mean, the holes are small, the pins are small, but I noticed some of the pins seems like they are bent. Like not a lot of them. If one of them is a slight angle bent, it's gonna be a problem to go in. I have to be trying to use my tweezer to assist, and see, I lose even one of the pin inside this bottom piece of the IC already. So yeah, it seems like I can have some problems with these. Let me see if I can fix this, and then, or maybe I'll just try another one and try to fix this one later on. Yeah, definitely not easy. I don't know if I'm doing something wrong, but I'm lining it up the pin as I should. There's a pin 1 on the IC and there's a pin 1 on the board, whereas there's a kind of cut out an arc, that half a circle arc right there. So we have to line that up with the arc on the integrated circuit but you can see here it seems like some of the pin, like maybe not all of them, one or two pins is slightly bent, and it's just being very difficult to get it to go to insert. Another thing, I'm wondering if I should actually complete the IC, put the top and the bottom on before putting it in, or put the base on first, then put the top on when it's on the board. That's something I'm trying. I don't know which would be best to get this on, because I'm worrying that when I get the base on, to line up the top with the pins might be a problem. So I don't know. Let me try, see if I can get this one in at least. Finally got it in with the help of my tweezer, but it's loose. If I turn over the board, it's going to fall out. So I'm going to have to put some solder on the tip of the solder iron and then try to tack it from the other side so it don't fall out. Alright, so one down, a lot more to go. Let's see if I have any luck with the rest of them. Hopefully they're easier to go in. So for this first set, I'm going to go with installing the base of the integrated circuit first into the board, and then try to put the top on while it's soldered and see how well that works out. Yeah, that went well, but it was an absolute fight. Took me quite a while to get all the integrated circuits in. I had to use my tweezer a lot to try to line up some of the pins. One or two pins were bent. Yeah, I thought it would be easier than that, but it was not so easy. Alright, so now I need to go through and completely solder all these pins for all these ICs. This is a lot of soldering. I've already done a lot of soldering already with the resistors, capacitors. I've done a lot of soldering. And then these IC chips come with so many legs already, so you can just imagine. So this is, like I said, it's an excellent solder practice, and I recommend this to improve your solder skills. So let's go through and just solder all these integrated circuits that are installed, and then I'm going to move on to try to insert the top of the IC chips onto the base. Hopefully those work out fine, no issues. Alright, let's finish this up. Alright, so now for the fun part. Now I need to install the top of the IC chips onto the base. If you look at the circuit board here that I highlight, we have to match the number that's on the IC chip with the number that's imprinted onto the circuit board. So I have to make sure that I match each accordingly to get it to work. And then I'm going to have to try to insert it to line up with the pins properly on the top of the base of the IC chip. Alright, let's go. So we have 6 IC chips in all, and they come in pairs with the top and the bottom, so that's 12. So right now I'm trying to put this one at the top, and I have to be holding the PCB board at all different type of angles to make sure that the pins line up before I put any pressure on it to insert it. So far it's not lining up as I want it to, and it's not being as easy as I thought it would. Every time I try to line up one side, the other side fall out, or the pins are very thin and they bend very easily. As soon as if I try to line it up, and if I line it up wrong, the pin can bend. So it's not as easy to install as it looks. You think it's going to be a struggle. Remember I said this method that I use here, where I install the base first and solder it, then try to put the top on. I need some help from you guys to tell me what's the best way to install these type of ICs. I think what I'm going to try next, I'm going to try to complete the IC first, put the top and the bottom in place first, and then solder it to the board. To me, when I'm handling it in my hand rather than on the board, it might be a bit easier to get it complete. So, but I don't know, just trying 2 different things and see which one works best. But so far, this is becoming a struggle. I think it would be a good idea if these chips came together rather than apart, because every time I try to line up one side, another side is out of place. Sometimes I got a few pins in, a few pins will be out, so I have to sometimes try to use my tweezer to push the pins in. Yeah, this is not going well, and I don't want to bend the pins because that would be bad. Yeah, I wish I could show you everything that I've been through trying to get these IC chips installed, but yeah, it would have been like a 3-hour video. This took me quite some time to get the 6 IC installed, and I think one of them got some of the pins got bent on one of the top at the top, and I don't know what caused it because I'm not seeing anything like any solder went in there and blocking it, but I don't know if that can affect it. I'll show you that later on, but for now, this was an absolute pain. This was the worst part of the whole project so far. Trying to get the top, especially the top part of the IC installed onto the base. What a nightmare. Alright. But, I mean, we'll learn from it and we'll move. I think I did, in the end, figure out maybe a strategy I can use later on. Install one side first and then use my tweezer to slightly pry the pins inwards and then apply some pressure to push it down. But the next method I'm gonna try is to complete the IC chips before I install it into the board. I'm gonna see how well that method proves. This is the pin I was talking about. I don't know if something is blocking it, but it didn't go all the way in and it bent at the top. And I'm just wondering if this is going to affect the functionality of this IC. Alright, so we have 6 ICs in, we have 6 to go, and now I'm going to do the handheld method. So I'm going to hold both pieces in my hand and then try to put it together before soldering it. I think this might be easier, but I'm actually kind of worried about how soft the pins are and how easy they are to bend. So me doing this, I have to be careful not to bend the pins while doing it. So it's just a matter of lining up the pins onto the base and then insert it. But even trying to do it here, it seems like the pins on the top of the pins on the top part of the IC, they are too wide off the base. So I don't know if you're supposed to like pry them inside before installing them. Like I said, I would love you can help me out in the comments on how to properly install these. But you notice at the side here, I have one side in and the other side is sticking out. This is the problem I was having when the base was soldered onto the board and tried to put it in. And yeah, so here I am now. I have one of the pins dropping out again. So I don't know. I mean, I have more handle over it this way, and I feel like I probably can get it done. But yeah, it's still not as easy. Every time I put one side in, another side come out. I think I can get it though. Alright, I finally get it after a little fight, but here's my problem now. Pins are bent. So now these pins that should go on the board are bent, so I have to straighten them. So it's like a double work. So which method is better? I don't know. I mean, I have more handle over holding them, but the pins are bending. This is going to be a problem, especially if I'm working in tight spaces to get these onto the board. So I probably think going with the method of installing the base first into the board and then put the top on would be the best method. But I'm gonna try this a few more. I'm gonna try this for the rest other 6 before I actually make a judgment on which method is the best. So far so good with these. I got this one done. See if I can get this one installed onto the board, tack it with some solder to hold it, complete the 6 of them, and then solder it off, finish off, and then see which method is the best. Alright, let's see if I can rip through this. Yeah, that was another long battle, and I could not let you sit through that again because it would be another fear apart again. So yeah, that took a while, and the challenge the challenge I faced the most was straightening the pins, holding them, and then trying to put the 2 pieces together. The pins bend so easy, so I didn't have to go back and straighten them. You know, more of the same. So now that I have all the ICs, well, I have one more still here trying to get installed, but I think installing the base first will be the preferred method. And then what I'm doing right now, I put one side in, and then I use my tweezer to pry the rest of the pins inside, line it up, and then apply pressure on the top. I think this is the method I'm going to go with next time, further up in the future if I'm doing this again. And a matter of fact, I'm going to do this again. I have to buy some of these ICs and get more practice, because this should not have taken me so long. This was painful, but alright, I got through it. I have all the ICs installed. So now what's left? I need to solder, and time for the big test and see what happens. Still a bit doubtful because of that that one bend pin on one of the ICs. I'm not sure, but let's not give up hope. Let's go. Alright, so after all that pain, I finally get to have some fun. Now, for the favorite part, soldering. Flux out, solder irons ready. Let's go. Cleanup time. Alright, finally done. All components installed, so the only thing left now is to apply power and test. But this project requires a 5-volt power. I have a 3 AA battery in a battery holder that gives me 4.5, but someone left a comment on one of my videos and said I can make a 5-volt using a USB charger. Actually, you know what, let me pull up that comment. It's from John Coops 6897, and he did leave quite a bit of advice based on the last video that I did, and these are the type of advice I definitely look forward to, because these just help me to learn and to correct my mistakes. Yeah, he said just to get a 5V power, cut off the end of a USB cable, then get power from a power bank or a wall adapter. And that's exactly what I did. I built a 5-volt with a USB charger, plugging into the wall, so no battery, and then perfect, works perfect. So I'm gonna use that one to test it, and I'm also gonna use the battery 4.5 volts to test it. That should work. I think that should work. All right, let's test some power and test this. Let's finish the project and see if I am successful. Fingers crossed. So I have the adapter plugged in. I'm just gonna test it quick to make sure I'm getting 5 volts. Yep, that looks good. Alright, I'm gonna go ahead and plug it in and see if I get anything. Alright, good. Yes, come on. Yes. Power is coming through. Yes, I see the second sticking off and the LEDs flashing. Yes. Woo. Nice. This is looking wicked. Yes, I love it. Alright. Second sticking out. Let me see if I can set the minute and the hour. pressing the buttons here, but I'm not getting nothing. Nothing at all. Ooh, yeah, this is not looking good. This is not looking good. I call it too quick. Getting power, the seconds working, but not able to set the hour or the minute. The push buttons that I'm trying to press are not changing anything. So right now I'm just checking to see if I have any ICs loose or anything, but not seeing that at all. Ouch. Alright, I'm gonna test with the battery holder. 3 AA batteries getting like 4.5 volts. Plug it in, yes. Alright, this is looking like it's working as well. Getting power, still not able to change the hour or the minute. So right now I'm wondering if it's the switch broken or what is going on. The fact that I'm getting power means that some things are connected properly, but probably something is not. I don't know. Yeah, I don't feel comfortable though calling this one a failure. I spent a lot of time on it and looking at it right now. Power ticking off, seconds running. I feel like I'm close. So as disappointed as I feel right now, I don't feel like I want to give up on it. I can't go like this.
Not like this. Not like this.
Yeah, so I think I need to take a break. Think about this. Think about how I'm going to actually troubleshoot this and then come back to it. Not giving up. Let's go.
Several hours later.
More like 3 days later, because I didn't get a lot of time to actually get back to this and try to figure it out. But I must say, I did figure it out. I got it working. So stay with me and let me show you exactly what I did, what did not work, and what worked. So in a nutshell, this is what I did. I checked the solder joints. I checked the bent IC that I was having an issue with. I checked the push switches, and then I rechecked all the components order if any was reversed. One of these checks that I did actually fixed my issue. The solder joints look good that I checked, even though I did have a few bulges on some of the resistors where the solder flew to the other side. But I don't think that was the issue. I didn't see any bridges. I was looking more for bridges and double pins connecting. So that looked good. So I moved on to the next step. That bent IC from the previously when I was installing the ICs, this one right here, I wasn't comfortable with it. So I just planned to remove this IC altogether, remove the socket, remove the IC, and then see what I can do from there. The IC socket had some damaged pins in it. When I took it off, some of the pins fell out. So what I did, I just installed the IC directly to the board, because the socket is just primarily a bridge to form the connection, and that allow you to easily replace the IC if needed. So I just remove it totally, install the IC directly to the board, and then I moved on from that. When I tested it after that, it still didn't work. So that was not my issue. So next, I move on to the push buttons. I think the push buttons were alright, but the fact that I was pushing, trying to change the minute and the hour, I was saying maybe the push buttons are bad, or I was actually thinking about the orientation, but I think these can be installed anyway. But changed those, tested it, still didn't work. That was not my issue. So now I'm down to the last step, which is to check the orientation of all the components, like the capacitors, the diodes. I know the LEDs work, so at least I know I don't have to check those because the LEDs work, right? So I just went through, checked the other components, resistors, diodes, capacitors, and yeah, surprise, surprise, the diodes were not installed correctly, and this was actually a rookie mistake, because the LEDs are diodes, right? Light emitting diodes, and I know that there's a short leg and a long leg. The long leg is the positive. When I was installing these diodes, the one in 4148, I did not know actually, because they are horizontal, right? So the legs are apart, and there's not a long leg or a short leg. At least I don't think there is. The black area on the diode is what tells where I think the positive side is, and on the PCB, that little box is where the black section of the diode should go to. So this was my issue. Once I went ahead, removed the diodes that was turned backwards. I think I had 3 of them that was turned in the wrong order. Replace them, well, reorder them, solder them in, then test, and everything was working. Absolutely magical. So, like I said, that was a rookie mistake. Should have known better. And one thing I know in electronics is that you have to pay close attention to detail. These fine little details, if you miss them, you have to go ahead and desolder and try to correct the issue. But I'm just happy that I finally get it to work, and my clock is working brilliantly as expected. Yeah, that was a journey. Now I can wrap this up, this video, and feel good about myself. And I must tell you though, I learned a lot in this video. So much things. I think my soldering skills improved because there were so much components to work with. This is by far the best soldering project I've done so far. And I know the moment I saw it, I know that I just had to get it to work with it because the amount of components. I'm going to put the link in the description because I feel like you should try it, especially if you're a beginner in electronics and soldering. Even if you're a pro, I think you would have fun building this digital clock. So now, very happy that I got it done and working, and I can mount it the way I was visioning in my head to mount it. So this is what I had in mind. I wanted to mount this up using some push pins onto the drywall close to my work area. Absolutely lovely. Look at that beauty. And it comes with a case, but I didn't want any case. I just want the raw PCB board, circuit board just laying on the wall with a clock ticking off. I absolutely love this. And now you understand why I couldn't give up so easy on this one. Regardless of there are a lot of hours that I put in, I really wanted to see this clock on my wall. Illuminated display, ticking away. Sometimes when I'm working in the night, looks very cool. Absolutely love this. Alright, so time to wrap up, people. Thank you so much for staying with me to the end of the video. Remember to drop a like, subscribe. Your support goes a long way. This was a long one. I think it was worth it. But like I said, I learned a lot, and I hope you learn a lot too. And I also hope you pick up this digital clock and try to attempt it, to build it. It was very much fun. It's a very cool project and I recommend it. So until next time, people, my name is Lex. Big up yourself. Peace out.